All right, today's project, let's fix this drawer. This is from an old desk at work. The front face of this drawer has come right off. Originally, it was held together with some finishing nails and some wood glue, and it's just come apart. So we're gonna fix this up. And I thought, why not 3D print a solution here? Because that's my go-to. Let's 3D print something. Some brackets, shall we? And let's reattach this drawer face to this drawer, and maybe we can incorporate one thing I've always wanted to try. Gridfinity. If you don't know what Gridfinity is, it is a free open source storage system designed by Zach Friedman, and people have been creating different containers and add-ons and holders and other pieces that connect to this system. And I thought, let's see if we can incorporate this system into my drawer fix, because like I said, I've always wanted to try Gridfinity, and this is a perfect opportunity. All right, so I went about this project in a very different way because I knew the dimensions of the drawer, and I knew the piece, the Gridfinity Baseplate, that would fit inside of this drawer. What I needed to do was create the brackets that I would use to help hold that face of the drawer to the rest of the drawer, and also allow the Gridfinity piece to fit inside of the drawer and basically help hold that in place as well. So it was all about designing the brackets. So I went about this in a different way because essentially I knew the dimensions of the drawer, and I knew the Gridfinity base plate that would fit inside of that drawer. What I wanted to do was just create the brackets that would help hold that face of the drawer to the rest of the drawer, and also allow me to slide in and secure that base plate inside of that drawer. So it was a bracket that I needed to design here. So in order to ensure that I would have a good fit and design for these brackets, I basically recreated the dimensions of the drawer in Tinkercad. This red piece I'm creating here is ultimately supposed to be the end of the drawer where the brackets will go. Now, inside the drawer, it had a width of 33.7 millimeters. So in Tinkercad, I basically recreated that same dimension, 337 millimeters across. And then I converted it into a hole to basically serve as a cutout. So this shape here represents the boundaries or the walls of my drawer. All right, next it is time to import the STL file for my Gridfinity base here. And I'm going with a 2x7 grid, just something simple to line just that front portion of the drawer. And the brackets that I'm designing will also help to lock and secure that grid at the front. So with this grid inserted, I'm actually going to use this as a cutout or a guide so I can help better shape and design my brackets. So here I'm just simply putting this base plate in there and positioning it where I would like to see it fit in relation to my drawer. So the walls of this grid are pretty straight. So if I were to take it and then extend it upwards, I've got a nice flat surface in which to work with. This is going to, again, help me shape out my brackets. So the dimensions of this cutout are 294 millimeters by 84 millimeters. And I'm actually going to make the dimensions of this cutout a little bit larger. So taking that 294 and making it 295, and the 84, I'm going to bump that up by another millimeter to 85. That's going to hopefully provide me just enough tolerance there so that the grid plate, when it does fit in, is going to fit in nicely, but it's not going to be tight where I have to basically push it in there. It should just slide in nicely. And that's what that extra millimeter is for in both the X and Y dimensions. So you can see here, I'm just taking this cutout and centering it and positioning it just right where I want it to sit in relation to the drawer. Again, that larger cutout that you see along the outside. And once this is in place and I'm happy with the position, it's time to design out the brackets. And for this, I'm going to break out the Extrude Sketch. I'm going to place it in that space between that outer cutout and that grid base that I have set up. And that provides me an awesome view where I can use those objects as guides to help me plot out the points where I can create the perfectly fitted bracket. That should hopefully help secure the front of that drawer as well as lock in that grid base plate. So basically what I'm doing here is I'm just sketching out the bracket, but I'm allowing it to basically overlap into those objects that I already have on my build plate, because those objects are going to serve as cutouts and should hopefully carve out a proper bracket that will fit perfectly in that space between my grid and the inside walls of my drawer. Would you call this reverse engineering the bracket? I don't know. Oh, well. Anyways, doing it this way allowed me to place the grid down where I'd want it to sit first, and then just simply turn that into a cutout and have the brackets form around it. And once I exit out of the sketch, you can see what I'm talking about. And actually, once I exit out of this, the last thing I actually have to do is take that grid plate and turn it into a cutout or a hole, and then group them together using union group, and let's see what we have. And there is my bracket. So all I got to do now is just increase the height of this object or my bracket so that it is tall enough so I can put in some pilot holes here and have the ability to screw this into the sides and front of my drawer. Now, because I centered my grid plate in the drawer, making the other side bracket for this is just simply making a duplicate and using the mirror tool, just simply flip it along the x-axis there, and I now have my second bracket. All right, next up, let's make those pilot holes for these brackets. It's going to involve the Revolve Sketch. So using Revolve Sketch allows me to create this pilot hole with a countersink really quickly and easily. Here I'm just creating a 4mm wide pilot hole for the screw, and then creating a separate shape on top of that for the screw head to fit in here. Again, creating this countersink pilot hole that will allow me to fasten the screw deeper into the bracket and not have the head of the screw sticking out. So to accomplish this, this sketch was actually the result of 3 different shapes that I made within the one sketch. The first one was just simply the main pilot hole, which I wanted to be 4mm wide. That was just a simple 2mm rectangle, and followed by a wider rectangle to allow for the screw head to push into that pilot hole. And the third shape was just a simple small triangle that would become a funnel-like shape so that the angled bottom of the screw head would sit flush up against that pilot hole. This was pretty easy in Revolve Sketch. And after that, just take my new Revolve Sketch, turn it into a cutout, and just position this anywhere I want along the brackets. Basically, I had 2 pilot holes along each edge of the bracket. Now, just to ensure that the depth of these pilot holes was correct, selecting the bracket and then pressing T for transparent just takes the guesswork out of this. And then next, select both pilot holes, duplicate, rotate them 90 degrees, and have them bore into the other side or the other arm of this bracket. Awesome. Select everything and union group. And rather than repeating this again for the other bracket, I just deleted that second bracket, duplicated this one with the pilot holes, and then just mirrored it along the x-axis to create the bracket for the other side. All right, so at this point, just import the base plate grid, the 2x7, and print it out, and we're good, right? Wrong. At this point, I started thinking about, well, how am I actually going to fasten this base plate to the bottom of this drawer? And this is when I decided I needed to change this design around the brackets, because I now wanted to add in some clips to the insides of these brackets that would help lock in or click in this base plate. And it's because I have so much space between the edges of this base plate and the sides of my drawer that these brackets already were quite thick. So I figured I can actually build more around this base plate so that I can create this solid clickable surface that would then lock into these brackets. So ultimately, I would have to redesign this base plate as well as now the brackets so that they would fit properly together. So in comes Extrude Sketch again, and I'm going to enter the sketch, but quickly leave the sketch so I can recenter the sketch on the base plate grid. And once I'm back in this sketch, I'm going to use this base plate grid as a template and guide so I can just simply add in some additional edging around this grid plate so I have plenty of space to have this click into the brackets. So basically I'm just adding in about 1 centimeter of additional width there to the sides of this grid plate and along that back edge of the grid plate. All right, so once this sketch is done, I have this oversized plate that I now want to merge with this Gridfinity base. So essentially what I need to do is I need to create a cutout for this grid plate and then use something like bundle groups to merge this sketch with the grid plate. Selecting that sketch and then pressing Ctrl H will temporarily hide it, leaving me just the grid plate to work with, and that's great because I just want to create the cutout. So using the exact same dimensions as this grid plate, I'm going to create a cutout that I will align perfectly with this grid plate and then bundle group them together. So now I'm going to unhide that sketch or show all and select both the sketch and the bundle group and then union group them together. I am really loving bundle group for this purpose right here. This just makes it easier and saves me a few steps. Okay, so with this redesigned base plate, I am recalling back or bringing back the cutout I was using for the internal dimensions of my drawer, and also bringing back the bracket that I had originally designed that I now need to redesign. And I also now need to place this newly redesigned base plate and align it properly to the center of this drawer space here again, so I can create another cutout and know exactly what the new dimensions of my bracket should be. And because this base plate or base grid plate is wider, that's where we're going to really see some changes being made to my brackets here. It's along the sides. Re-entering the sketch is easy. Just double click on my object and I'm back in sketch mode. And here again, the beauty of this is that I can clearly see all of the other pieces on my work plane. And that means that I can readjust my sketch to ensure that it is fit closely to this, and again allow these pieces that I have on my work plane to serve as cutouts to ensure that I have the perfect fit for the drawer and this newly designed grid base plate. Similar to what I did the first time, I'm just taking this grid base plate, making it just a little bit wider, again, just by a few millimeters on either side to increase that tolerance, and then just extending it upward to serve as a cutout so that I can make sure that these brackets are fully cut out and should be the correct dimensions to hold this grid plate in place. And here I'm just using another cutout to clean up one of the indentations on this inside of this bracket that I just didn't want. I wanted this to be a nice smooth inside surface, so I'm just shearing that off with a carefully placed cutout using the workplane tool. Now in changing the width of the sides of my bracket, I just wanted to make sure that these pilot holes were still situated perfectly, so I just made this transparent by selecting the bracket and pressing T. And with the pilot holes still looking great, time to move on to the next step. All right, next it was time to design some tabs that I would use to click and lock in the grid once it was pressed into place. And for this, I used a box that was quickly reshaped into a thin tab, and then Extrude Sketch onto that so I could create that angled piece that would help lock in the grid plate. So the idea behind this angled tab is that the grid plate would slide past this and force the tab backward into the bracket, and as soon as that grid passed through it, this tab would then click back out and lock this grid plate into place and prevent it from lifting up. So not only did I have to place the tab into this bracket, I also had to create a cavity for this tab to move backward into that bracket as the grid plate was pushing past it. So at its thickest point, this tab was 4 millimeters thick, and so I decided to go with a cavity that was 6 millimeters thick so that there would be plenty of space and clearance for this tab to flex backward into the bracket. So this is the creation of yet another bundle group here, because once I align these two pieces together, it is a cutout as well as the new tab. This new tab is going to fill in the space that this cutout will create in that bracket. And so this is the perfect application for bundle groups. So here I'm just carefully aligning these two pieces, the cutout hole and the tab that will go and be inserted within this cutout. The top part of this tab should sit flush to the bracket, but it's that bottom angled piece that should stick out by about 2 millimeters past this bracket piece so that, again, it will help lock in that grid once it slides past it. Once I was happy with the placement of the first tab, it was just a matter of duplicating it and placing the second one along the other wall of this bracket. Oh, and the other important thing to note here was the height of this tab, because this bottom part of the tab had to clear the top of this grid plate once it was placed down onto the floor of the drawer. So it was about maybe 1 centimeter off the ground here. So once these bundle groups are in place, it's just a matter of selecting all of these items now and union grouping them. And in doing so, that bundle group ends up cutting out that hole and essentially inserting in that tab in its place. Okay, this was yet another quick redesign here, and it was around those tabs because I needed to think about how I was going to print this up, and I don't want to use a lot of supports here. So those cavities that I created for these tabs do not extend all the way down to the ground. And so as a result, this becomes a bit of a tricky thing to print. So the best way to print this up without having to use a lot of supports would be to print it upside down. And the one last thing I needed to do was essentially take that cutout, that hole that I have there, and extend it all the way down to the ground. Doing this would allow me to print this up without any need for supports when this bracket is flipped upside down. So recreating these bundle groups and then union grouping them back with the bracket, easy fix, and it obviously solves a printing problem for me. All right, just some finishing touches here. I'm using another Extrude Sketch and placing it along the edges there of my bracket just to create a beveled top edge by creating a quick little cutout that I can apply to the edges of my bracket. Just a minor design feature, and yeah, we're really close to being done here. Once that first bevel cutout is made, it's just a matter of duplicating it and reapplying it on any other edge I want on my bracket. And in spending and investing all of this time designing this first bracket, making the second one is an absolute breeze because I basically duplicate it and then mirror it so that it is the opposite side of the drawer. Awesome. Okay, the last thing I need to do here is deal with this base grid plate because it is far wider than my actual print bed. And so I need to print this up into two pieces here. So I'm just carefully placing a cutout where I'm creating the one half of the grid and the second half of the grid. The two pieces I will need to print up and later assemble. I'm assuming I'm going to glue these together and create one grid piece. All right. Once this is done, let's print these up. All right, printing up the pieces, no problem. Grid plate, check. And of course, I also printed up some simple containers that I will fit onto the grid once this is all assembled. Now, I also cleaned up and reassembled the drawer using some wood glue before adding in the brackets. All right, the brackets look like they fit okay, but it's the moment of truth. Time to put in some pilot holes and screw these brackets in. Now, I am not a carpenter. I don't pretend to know what I'm doing when it comes to this kind of stuff. So those that do, avert your eyes because this could be a little bit painful. All right, next it's time to lay in those Gridfinity base plates. Now, I didn't get a chance to attach them and glue them together. I was just really curious to see if they would even fit and snap in properly. It clicks in. And in fact, all I wanted it to do is just not come out. The grid plates fit in perfectly. And even with them not glued together, they did not move and want to come out and lift out of those brackets. So I just left it the way it was. I thought it was perfect. And now the final touch, it's time to add in those containers and let's finish setting this up. Everything worked out perfectly. Everything fit, and this drawer is back in one piece again. I mean, time will tell whether or not this design is going to last and if it's strong enough to hold this drawer together, but I just love the fact that I could take this existing Gridfinity design and modify it to fit my own needs. And being able to use Tinkercad and my own 3D printer to make this happen, it's just awesome. All right, until next time, take care, and we will see you on the next video.